Kelly, it's super nice to be here with you. Read a lot about you, heard a little bit about you as well. We really are excited about our conversation today. Rodrigo, do you want to kick things off?
Yes, for sure. I would love to say thank you also. And I saw your interview after the LaterCon. You shared some of your thoughts. Then I thought, oh, why not? I think it would be a great pleasure to have you in our show, Merging Minds. So it's which is promoted by BureauWorks, our company. So it's where we invite people like you, like that can contribute with some thoughts on our industry. Sometimes we get a little bit philosophical, but I think it's part of our the way how we operate. You said in our conversation that your experience it's around machine learning and now you are more in research. If you could start a little bit, introduce yourself and share a little bit what you do at Cohere.
Mm-hmm. Sure. So I'm Kelly Marchisio. I am the multilinguality lead at Cohere. I lead the multilingual modeling team. So we do basically everything throughout the entirety of the modeling pipeline towards building our flagship LLMs that has anything to do with behaviors outside of English. So that could be choosing the languages that are going to go into the next big model, thinking about what the pre-training data will be, SFT and preference data, getting that data, cleaning it, running ablations on the model, seeing what the data does, getting public evals, also coming up with our own evals, even all the way to thinking about what annotation resources do we need and what languages to assure the quality in the languages that we care about. So it's really a bit of anything that you can imagine that needs to happen to build a state-of-the-art multilingual LLM. How I got into this, I actually studied educational psychology as a graduate student immediately after undergrad, got introduced to computer science, my whole career changed. The long story very short is that I was at Google for about 3.5 years as a customer service agent and then a web developer. I then started in academic computer science at the University of Cambridge, where I studied natural language processing, did a PhD at Johns Hopkins University, focusing on machine translation and multilinguality. That was for 5 years. And then after my PhD, I came to Cohere as an individual contributor, research and machine learning engineer. And I started the multilingual language processing work that happens at Cohere. So I was the first one to integrate our pipelining with supervised fine-tuning, preference, implemented some of our first evals, and showed that it was possible to make a good multilingual LLM at Cohere. I worked as an individual contributor at Cohere for about 1.5 years, and then started leading the team as the tech lead and manager in January of this year.
Oh, nice. Very nice curriculum. So it's been a lot of new names that we can talk about it, a couple of names that you just mentioned. One thing I would like to start this conversation is basically about one of the things that you said during the LaterCon interview, that you have said that multilinguality is not a feature, it's a foundation. So what does that mean in terms of, in practical terms, from a user perspective? Could you please extend a little bit on that?
Sure. So I think if we talk about English, it becomes very clear what I mean by it is not a feature, it's a foundation. So if you say, oh, I want my LLM to be really good at English, what do you mean by that? Like good at math, good at general chat, good at translation into English. So then you can see why if we say, oh, I want my LLM to be good at Japanese, what do you actually mean? And if you really want your LLM to be good at Japanese in a general purpose capacity, then it needs to be good in a variety of tasks, maybe the same tasks as in English, maybe to the same level.
Okay, so for an user perspective, the big difference is I can switch between languages without having any drawback in terms of output. It's that the way how we as users can see the difference?
Yeah, that is the dream. Ideally, if a user can interact with an LLM in English, but then they are more comfortable in a different language, let's say they are more comfortable in Japanese, I think they should be able to interact with that technology in the language that they feel most comfortable in whatever task, without having to switch to a language where they're less comfortable, or maybe which is like not even relevant for the particular task.
Nice. And when we compare to those LLMs that aren't multilingual since the foundation, they tends to have more issues when we do this, when we switch from a language to another. Is that correct?
Yeah, like you might find if you are using an LLM as an agent on some type of tasks or to do some math processing, maybe you might find that if you ask the math problem in English, it's solved correctly. But if you ask in a different language, the model is trying to think and it doesn't really think very well. Maybe it code switches half Japanese, half English, and maybe it gets the wrong answer. So a lot of these issues come up when you use an LLM, especially if one claims to be multilingual but hasn't been obviously trained to actually be multilingual.
Oh, nice. I'm not aware if how many LLMs they are explicitly multilingual. It's the first time that I heard, like it was after your session at LaterCon. Do they also advertise that? Like the first time that I saw it, just asking if from a user perspective they all are, or is just Cohere?
So they are definitely not all multilingual, but it's also not just Cohere. Different companies will support a different variety of languages on different tasks. You may see LLMs say that they are multilingual, but the only eval they've provided is MMLU. MMLU is a question answering data set. So there might be questions about biology, which are translated into Japanese. The LLM provider might say, oh, we perform really well on Japanese because we get a great score on this Japanese biology exam. You can see that that's a limited domain. So some providers you will see claim multilingual capabilities in a very limited set of evals. I would say that Cohere is one of the few that really puts multilinguality first. So we think about this throughout the entirety of the pipeline. Like everything is designed with multilingual users in mind, and that's because we are building for global companies. We know that if you're working in Japanese or Korean or a variety of other languages, maybe you also need to work in English. Maybe you need to work in the languages of the region where your headquarters is in. And it takes care throughout the process to make that all coalesce and work nicely. It is not, multilinguality is not something you can just sprinkle on the top of an English model and hope that you get something that works at the end.
Yeah. No, definitely. We, of course, I'm not aware exactly of all the details that it's necessary to create this multilinguality in terms of models, but just creating an analogy, our sector, it's talking a lot about how to introduce, mainly in creative agencies that are in charge of getting a brand, a big slogan, and turning into, and localize all this slogan and this copywriting into so many markets. And then they've been talking about how to let all this localization process, it starts since the beginning, instead of just, like you said, in the end, and just sprinkle some flags or some colors according to the country, but it starts since the beginning, this transcreation process. So it seems even, from the human in the loop side and the automated side, it seems both are converging into this, how to bring localization since the early stage of this creation. So it's just an analogy that I make in our sector. Well, we were talking some minutes ago, and then we talked about some terms that we think it's important for our listeners, people who is listening to this show. And we talk also about localization manager. And then I was a little bit intrigued because it's been since when I started at BureauWorks, localization manager. It's a kind of regular term that we talk a lot. And then I was surprised that it was a new term for you.
Mm-hmm.
And then I thought of how our worlds are so apart in terms of specifications, and then what is the regular and the common words that we talk. And then because I was intrigued by one job advertisement that went viral 1 month ago or so, it was basically they were opening a new position for a localization manager, And many people in our industry, they saw this advertisement and they said, oh, you see, even OpenAI, they need also a localization manager. And then I was intrigued to know from you what are your thoughts on this automation and how you see from your perspective these two worlds coexisting. One world where you can turn and you change and you can see that every change that you apply in the model reverberates in many use cases. And while the other world, so it's much focused on, a more specific use case in a given industry. Yeah, I would like to know from you, like, what are your thoughts on that, and how do you see these two worlds coexisting?
Cool. Yeah. So I was thinking about this question earlier today. And yeah, just to reiterate what happened between the two of us, you'd asked me to say something about localization managers. And I was like, what really is that? Something I've heard about before, but I don't come across that term very often. It's not part of my day-to-day life because I'm very much on the build the model as general purpose as you can. And then, for instance, at Cohere, we have some forward deployed engineering teams that will take our general purpose model and maybe they'll customize it for a particular user in a particular language or a particular use case. A lot of times I will hear from those groups doing that, or I'll hear from some like project managers or occasionally some customers. But in reality, like 98% of my time is spent thinking like, how do I make this thing general purpose? And then what someone's going to do with it after that, it's going to be based on their specific use case. So the example that I was thinking about, I have a 1-year-old daughter, and every morning I get up with her and we wait till dad gets up, we play, and then, he and I start our work days. But while we are playing, I am in the process of trying to improve my French and Spanish. So I attempt to speak to my daughter in one of these languages. And yeah, it's pretty fun. But I use Gen AI technologies to do that. So I find that my like French and Spanish, if I'm talking about academic topics or like talking about myself, is pretty good. But when I'm saying things like to a kid, like put your socks on, or like you can't put both shoes on the same foot, these are not phrases that I ever came across in school. So this morning, she was trying to screw a top on my water bottle and it had like flown across the room. And I tried to translate with like a speech text translator, like, go get that top. And then I realized, how is it going to know what I mean by top, like top of a mountain, top of a water bottle, whatever. And then because I know a little bit about the technology, I was like, okay, let me verify that this is the right translation. I will ask it to say, go get me the top to that water bottle, in hopes that by putting water bottle in context, it would choose the correct word. Now, my French is not good enough to know if those words are actually different in French or not. But the point is that I knew that without the context, the neural model would probably not get it right if there was like a false friend. So I think that is where the role of localization professionals come into play, because if I do just deploy a translation technology, how could a machine know, especially if it doesn't have like vision and it can't see the room that I'm in and it can't see that I'm playing with a water bottle with my kid, how can it know what the correct word choice is there?
Yeah. And also with such a short, a message that, like you said, you didn't give any context. So
yeah. So I don't know if I answered your question or if I just told a cute story that happened to me this morning, but regardless, that's my perspective.
the story is pretty cool. It's really hard, these basics, instructions in a second language, how, and when you don't live it in another, environment. So it's I understand like your analogy, like how the model is going to know the context. If so, that's what I understood. It's there is still a world where we're gonna need all these human in the loop, because they give more context to the model, and with more context, the model can process more information and be more accurate in terms of, because the human, it's feeding all these context, right?
And you can imagine, like, in the context of that word top, like probably the model has seen like a top to a water bottle. It's probably seen a mountaintop, but I can imagine other domains, like more esoteric domains that it would not have seen in training. And because what the model outputs is based on the statistics of the training data that went into it, in an unfamiliar domain, it has very little hope of getting that correct.
Okay. Yeah, it makes sense. It's mainly, we launched a new feature called Free Flow, and our Free Flow, it's basically, it's a translation editor without segment. I could see how that even, it could happen in one of cat tools. I don't know if you know cat tool, if it's something that you know what a cat tool is, Kelly.
You're going to probably have to remind me. Again, these are the things that I like get bits and pieces of, but our worlds are pretty separate from each other. So
Yeah.
I'd love a definition.
A cat tool, it's a computer assisted translation. So it's basically where it's a piece of software that gets the documents and ingests all these documents and parse and break it into small chunks, what we call segments, and save all the segments into a translation memory. So a cat tool, it's essentially where a translator work daily with the source and the target, and they have all these segments breaking, all this content breaking into segments, and they can translate segment per segment. So yeah, basically it's that. So I can imagine in a scenario where even this example that you just shared, they could even the LLM, they wouldn't have enough information because it's such a small piece of information. And then now with our free flow, what we are suggesting, it's the same environment but without all the segments. It's just a full context, a full text.
Yeah, and this is a big challenge in modern AI, is these long context tasks. If you have to do some task over extremely long documents, that gets more and more difficult the longer and longer the context is. I certainly agree with you that translation very often needs context, maybe even a very long context. And that is something that we are working on, but yeah, it's not an easy task.
Yeah, there is somewhere in the middle that just one phrase is not enough, and then also if you send a whole book, it's too much. So where is this middle, in your opinion? Where it's too much? What are the limits today in terms of context that we can provide to an LLM?
Yeah, so interestingly, this differs based on language. And to make it fun, I guess I will get slightly technical. So most providers will tell you what their maximum context length is. That'll often be their context length in English. An important concept, which I talked about at SlaterCon briefly, is tokenization, and that is how you split a sequence of characters or words in a certain language into little units that you can train on. The splitting will dramatically affect the context length. For instance, the worst possible scenario is that a character needs to be put down to the byte level. So if during training you did not see Hindi characters ever, maybe that would get split to 3 bytes. And I think there are even some characters in some languages that might even get to 4. So you can imagine, like, if in English the word dog was 1 token, but for some reason that needed to be split down to the byte level and it ended up like 10 tokens. Now, if your context length was claimed to be 100,000, but you're splitting so much that each individual word is taking like 10 tokens, then effectively you cannot have the same amount of information in the context in like Hindi or Japanese as you can in English. If the tokenizer is well designed, this gets better. But it is impossible to fit it's impossible to optimally tokenize every language in the world.
So that probably would affect not just the price, but also the way how the system retrieve and search for these tokens, right? Not just from a pricing perspective or a cost perspective, but how precisely the model retrieve these tokens if they are in a subgroup or if they are splitted. Is that correct?
So the link between what's called tokenizer fertility, so that's like, does one, let's say, word or one unit get blown up to 1 token or 4? This whole concept of like how much is a semantic unit blown up into is called tokenizer fertility. There's not a strong link that I'm aware of between tokenizer fertility and downstream performance. It's hypothesized that like the worse the fertility, so the more you blow it up, the worse the performance is. Perhaps this has been verified for some tasks. I would have to look into the research to actually verify that. But I think it's fair to say that if you are working in a language where you're consistently getting your number of tokens to be very high, you are both probably getting worse model performance, and you are almost certainly getting charged more. Definitely not all providers will charge based on token, but if you're getting charged based on token, then you will be paying more for that.
Sorry, Rodrigo, I don't mean to interrupt. Whenever you're done with your question, I have something that I want to ask.
No, go ahead.
Kelly, by the way, I've been learning a lot, so thanks so much. One of the key motifs that I've been hearing here is we have very different vocabulary to talk about essentially the same problem, right? We're solving it from different angles. You're solving it perhaps at a much more foundational approach. Our industry has been solving it at a much more transactional approach, making sure that documents get well translated. But ultimately, my feeling is that these things at some point converge, right? And my first question is, so when you're talking about you being the head of multilinguality and if I understood correctly, your mission, is it to make sure that Cohere performs well in as many languages as possible, or is it to ensure that Cohere can also translate well between languages, or are both completely interconnected?
So I would say that they're interconnected. Cohere's flagship model, Command A, supports 23 languages. There's also a model called Aya, and they released an Aya 101. That was by Cohere Labs. But just by the number alone, you can see that Command A, which was by the for-profit side of Cohere, is thinking about depth in those languages with 23 languages. Aya was more thinking about breadth. I personally, because I'm at Cohere and we're thinking about business context, I really want to make sure that the quality is very high in the languages that we claim to support. Of course, I would love to support all the languages of the world. That's not possible. So we do have to make trade-offs. But the personal goal of mine and of my team is to build the strongest general purpose model possible. And then we do work on machine translation. So we will make some tweaks to try to make it the best machine translation model possible. We will, for certain customers, hand it off to some of our forward deployed and applied engineering teams, and they will customize it for particular customers for particular languages. So my goal is give the best possible starting point to all these other teams who know what their use case is, they're specialists in their thing, and they will customize the model towards their goal.
Got it. So if I'm understanding correctly, if you succeed and you work well at the multilinguality level, that ensures that then any solution that's a subset of that, like machine translation or like trained behavior between languages in one way or another, that's going to perform well because you've done your work well. Am I understanding correctly?
Yeah, exactly. So maybe I would try to make a really, really good machine translation model, but you really care about Japanese, Korean translation. So you're just going to do a little bit of tweaking, because I couldn't foresee in advance, that's the specific thing that you care about. But I want to make something where when you do try to make it customized to you, it'll be not so difficult to do that.
Cool. And I don't know if you have a very clear opinion on this, but in your opinion, not just opinion, how would you describe the main differences between, let's say, running something through a neural machine translation engine like Google or Microsoft versus running the same content through through Cohere, for instance, or Command A, or any other specific application that you have? What happens to the text, and how is it different, both from a computational perspective, cost perspective, user experience perspective? Yeah, would love to learn a little bit more about that.
Yeah, sure. And then here's where this difference emerges, because let's talk about the computational difference. When it gets to cost and user experience, that then becomes beyond my realm of expertise, but of course I hear flurries about these things. But in terms of neural machine translation versus what is happening now in LLMs, I would say that LLMs are an evolution of neural machine translation. Traditional NMT systems were built for the single purpose of machine translation. That means they can be small. They tend to be what's called an encoder-decoder architecture. So they take the source sequence in, they encode it into like a vector, and then they decode it. And they know that their task is to do this loop of machine translation. What is different now, and for a while, by the way, those systems were really outperforming LLMs. It's only recently that LLMs are able to achieve the quality or better that NMT systems can do. What is really nice about LLMs is their instruction following capabilities. So you can say, I am talking to my boss and I need this translation to be very formal and some other parameters. And the LLM can handle that, whereas the neural machine translation system can't handle that instruction. So it would give you a single answer, or maybe if you have some like temperature parameter, maybe you could get a variety of answers from an NMT system, but you can't directly steer it towards like, I want this style, I want to like put a translation dictionary into context, make sure you do this, make sure that you keep all proper names, all caps, or think like little instructions like that NMT systems cannot do unless they were specially built for that. And that's why I really like LLMs, is because I think there's a great promise to use them for a variety of tasks, but particularly translation, where the user is going to want to add a little something extra that they can add via instructions.
That makes a lot of sense. So if I'm understanding correctly, there's a similarity in architecture between an NMT and an LLM. The NMT is working in an encoder-decoder structure, whereas the LLMs are working in a transformer structure. Is that correct, or is that are they different?
So NMT systems were typically transformers too.
Transformers too, okay.
Yeah, but the LLMs, basically you don't do the encoding and the decoding. You just are only doing the decoding process. But honestly, like technically they're quite similar, like evolutions of one another. NMT systems can probably be smaller at the same quality than if you want a general purpose LLM.
But okay, so basically the NMT is a less sophisticated version of an LLM, less parameters, less things going on, and you can't emulate semantic awareness at an NMT level, right? You're still operating with simpler operations of language. Am I correct? Or
yeah, well, you can imagine an NMT system would have been trained on like pairs of source and target. Like learn how to do this translation, learn how to do it. Whereas the general purpose LLM will have had some of that, but also have had some of like, speak to me in a pirate voice. So then at runtime, the hope with the LLM is you can both get that translation and also the speak to me in a pirate voice coming out in the same output. But technically, the field has very much converged on transformers.
Cool.
So a lot of the, I used to work on like, I guess you can call them traditional systems, which is funny because it is also very recent memory. But yeah, the technical skills involved with that are similar to what I would do now. So
if I'm understanding correctly, the NMT by design is going to be a lot less computationally intensive and consequently faster and less expensive than an LLM. But an LLM will be a lot more powerful, deliver more sensitive results, be able to extend semantic inferences from the text and from the users, etc. Right? So that is that a fair statement, or?
Yeah, I'd say that's a good way to put it. And then, and of course, you can make smaller LLMs, you can make bigger encoder-decoder systems, but in general, like single-purpose systems can usually be smaller than if you want somebody to be general.
Okay, so just to like try to really pinpoint where the evolution gap is. So the NMT, it wouldn't be fair to call it like a small LLM, right?
That would not be fair.
Right.
Because
there's something that
you will like encode it into a vector and then decode it out into words. Whereas the GPT like systems will just do the decoding phase. They don't have like a source that, well, it's just a different architecture.
Yeah, but I'm just trying to pinpoint exactly where the paradigm shift happens, because it's not, you mentioned evolution, right? But some evolution is linear. and
Yeah.
maybe like let's say you talk about characteristic Darwinian evolution, and you see the lineage between chimps and humans and how eventually they start walking on 2 feet, but you can see how it's still the same line.
Mhm.
At least the way it's was taught to me, you don't see like a burst. You don't see like all of a sudden, wait, what happened here from point A to point B? From what
Mhm.
you're describing, I'm understanding that there is some kind of burst that's fundamentally different in the LLM as opposed to the NMT? Or is it just a matter of complexity and more parameters? It seems to me that it's not just more parameters, there's something else going on.
Yeah, so it's the difference, and I would say we should both look this up after, but it's the difference between NMT being this like encoder decoder architecture versus LLMs being this like decoder only. So like half this technical system has basically disappeared.
Okay. If all of the decoding or all of the encoding part has disappeared, how does it still operate? Because it's something that I try to write a lot about, and I noticed that I'm kind of ignorant as opposed to, when I get to really like the nitty gritty about where the differences lie between, I mean, some stuff is easier to explain. Like, let's say the difference between like a rule-based model for machine translation versus statistical. I can explain that to my kids. One is like you're basically following certain rules and you're programming these rules, and the other one you're trying to follow statistical probabilities of events in language. I can understand that. I can explain that. When we begin talking about neural machine translation, it's actually, for some reason, it's harder for me to explain that compared to LLMs. Like, I can understand an LLM from a conceptual perspective, and I can explain it to my kids better than I can explain the neural machine translation part. Maybe it's just because there's less literature about it, or maybe it's just some incapacity of mine. But yeah, I really, I'm one of the things, and again, maybe you're right. Maybe we should just read about this later. But I'm just very curious about, where that gap lies and how did it happen? Because
Yeah.
again, this is kind of what I find super fascinating. Like, LLMs and language are super connected. Right now, they're using LLMs are primarily used for general purpose activities, but fundamentally, it was about predicting the next word,
Mhm.
and that was also very connected to translations and things like that. But so, in my general sense is that all of this is kind of tied together. But yeah, I wanted to be, for me, the test of my knowledge is, can I explain this to my kids in a really detailed way so that they can understand it? And if I can't, I feel like I'm missing something.
Yeah. So yeah, I'm trying to like bring up a picture because I have a picture right now of like a transformer encoder decoder architecture. Can I screen share? Maybe I can't screen share. But I think if you look up like encoder decoder architecture, and now I'm going to look up like versus decoder only and just try to get an image. Yeah, that's probably kind of a good way to do it. I'm like on Google image search right now. And it's showing you that like in the encoder decoder, like everything is about next word prediction. But when the decoder is happening, it's either pointing back to some encoded representation of the source, which is encoder decoder, or it's not.
Got it.
Yeah, so I'm seeing this image right now that's talking about like encoder BERT and then decoder only GPT. So yeah, I encourage looking up those images.
Got it. Now I'm understanding. So if I'm understanding correctly, when you're encoding, decoding, you kind of hinted at this, but when you're encoding, decoding, you're working in a much more constrained problem that you're solving. You have a string that you're encoding, and you want to decode it in Japanese or Korean or Portuguese in a different language. It's a very simple operation that's taking place with one particular set of strings, and you're using neural networks to do a better job at decoding, basically, right? You're like in that process of in the process of encoding, decoding, you're trying to reach higher accuracy, whatever accuracy means. Whereas in LLMs, you're working at the embedding level, so everything is a mathematical representation, which doesn't require objects to be encoded and decoded. They're just existing in that vector realm and being then represented into words.
Yeah, so there was still the concept of embeddings and vectors and everything with encoder decoder. So and it is definitely still complex, even when you're talking about ones from 2017, 2018, because I remember during my PhD, people saying, oh my gosh, like so-and-so can train a BERT model. Can you believe that? I think it was like 350 million parameter. One of the major models was about 350 million parameters. And now we're talking billions. So even NMT systems are definitely complicated and no one understands what's going on in the inner workings of them. But yeah, they were purpose built, like get an encoded representation, contextualized on that, just do the translation. You've been trained for this. Not a mystery what I want you to do. I'm not telling you do translation. It's just like when you see text, you just translate it. That's just what you do. Whereas in an LLM, you need that instruction, like I want you to translate it, and then it knows what task it has to do.
Right. It's working with much more dimensions of possibilities of outcomes and things like that. Like you said, you can introduce intent and you can introduce all kinds of specific task goals and larger contexts. I think now it's a little bit more clear. I still want to read up more about this, but it's a little bit more clear. So, okay, so you're working on multilinguality. That's more clear to me. Mm-hmm. And we still, I think, have a huge gap in terms of vocabulary, right? You're talking about fine tuning. You're talking about data. You're talking about parameters and the transformers. You're operating in the large language model universe, right? Mm-hmm. Our space is operating in this paradigm of machine translation memories, glossaries, projects. It's a very different space, very different thing, but somehow they're converging. And the way they're converging, in my opinion, is fundamental, at least right now, it's a lot driven by users who are challenging the idea that you need a human to make translations great. And I would love to understand a little bit your take on this. You mentioned a little bit about like the human supervision as far as adding spice with intent and things like that. But in your opinion, where are we now in terms of how good are the outputs right now? Mm-hmm. And where are we going to be in a while? When you can define a while, whether it's 5 years or 10 years. And we'd love to hear your thoughts on that.
Sure. So one of the major challenges for machine translation will be getting things right across domains. So like regardless of what you're talking about, get it right regardless of language, especially if it's a low resource language. So where are we now? I'd say that we're pretty good at doing like news translation. There's a major machine translation competition every year called WMT, the Conference on Machine Translation. They've historically had a news task. We're pretty good at news translation. They've made the test sets harder to cover other domains like social and other things. I'll tell another anecdote. So I was somewhere last week and somebody was talking about using machine translation technologies and like not checking the outputs. And I was taken aback by this. I didn't really say anything at the time because I was not directly involved in the conversation. But my perspective on that was, if you're texting your friend and it's very low stakes, whatever, machine translation output. But if you're in a legal context, if you're in finance, whatever, this really matters. And someone brought up the case that say you have a legal argument in English and then you try to translate it, but the word, and say it's like an ironclad thing in English and it's saying you must do this. Maybe you translate it to German and the word that was chosen is kind of softer. It's like, it's a suggestion. Maybe you should do this. This entirely changes the legal argument. So the big risk in not checking your outputs is you could just change the meaning. You could poke holes in a legal argument. So I'd say where we are now is, machine translation, automated machine translation is pretty good in a lot of contexts. Errors absolutely exist. They are higher frequency in more esoteric domains, especially domains where you have to be right, where there's like one right answer. I can even think about like if you were to translate some like math problems, that would be difficult. And I would expect errors to happen there. Obviously, the goal is that we do this right, but you'll, just like the example that I brought up with go get that top that I said to my daughter, without the context, you can't get that right. And that via text only LLMs, I would say, is not possible to solve. I hate to say impossible, but without knowing what room I was in and what the objects around me were, how could even a human, but especially how could a system ever get that right?
Got it.
Right. That's where I think we are.
That's interesting. And I have a few points on top of what you're making. But one is you're describing, like, let's say a text message between friends is low stakes and the legal scenario is high stakes. But just a challenge there. Like, let's say
Sure,
I'm texting Rodrigo, for instance, and we work together and we're friends. And let's say we're talking in Spanish and I say te quiero, Rodrigo. And te quiero in Spanish could be typically between friends say it to each other all the time, and it means I like you. It doesn't. There's nothing along with that, but literally it means I want you.
Okay.
And all of a sudden, we're in a working relationship, and all of a sudden he gets a text from his boss saying I want you, and that's all of a sudden what's low stakes just went into really high stakes.
Yeah.
So it could be a simple translation mistake, but all of a sudden I'm confusing intent completely, and Rodrigo's feeling harassed by me.
Yes.
So I find it interesting just because, typically when I talk to people will typically think about legal scenarios as high stakes and personal scenarios low stakes. I tend to think of language as potentially high stakes in anywhere. Just say the wrong thing at the wrong time, and you could be really offensive. You could destroy a friendship. And those things matter. Like, they have a lot of value. And I would argue that, typically if it's a contract, that's something high exposure. Even if the translation itself doesn't get checked word by word, the final version of the contract will be read by people, often multiple people, and that's going to be somehow seen, whether or not at the translation level, at the content expression level. So that's just one interesting point that I always find. It's like, I think that's my personal opinion. I just think language is sensitive in general, period. I don't know how you think about that.
Yeah, definitely. I mean, and I guess if someone understands, like, hey, you're using translation technologies and this could make a mistake, and they're actually your friend and they're gonna, cut you some slack. But if it's your boss, or if it's somebody that doesn't understand you're using a translation technology and thinks you just said it in your native language, that could be very awkward. Yes.
Yeah, but I think that's something interesting that you're talking about, like the cutting of slack, right? I think you talked about language and accuracy and quality. You used accuracy and quality, right? And this is something I want to ask you, because my opinion is the idea of good enough is always something that's a very moving target, right? It's good enough for what, right? So it's like you mentioned the news, right? Maybe it's good enough for me to understand what the article said perfectly, and that's good enough. But maybe it's not good enough to get me to stay on the page and read another article. Or maybe it's not good enough to get me to subscribe to that news service. So the idea of good enough, at least my understanding is that it's a moving target. And yeah, would love to see what you think about that.
Yeah. And I think this underlines the fact that there is this distance now. And I think in some senses there has to be, because, not everybody can be a master of everything, and we need to build general purpose things. But I think that's where, people who are knowledgeable about what the downstream use case is going to be will take the technology the extra mile to make it actually work for the thing that they care about. Because it could be that your use case is very different than Rodrigo's use case. So I can't build it just for you, because then it's going to mess up Rodrigo's. I got to build the thing that either of you can make customizable for yourself.
Yeah, that's a part I find super interesting about languages. It's, in my opinion, because we're getting into a place where it's going to be architecturally and computationally possible to really assess the performance of things almost in runtime, we get to the point where we could live in a world where the three of us are reading different versions of the same news. It's like slightly different, maybe fundamentally different, maybe the same news, but social media already kind of does that algorithmically, like where your feed is going to be different from Rodrigo's or mine. But now we're talking about maybe actually reading the same post differently. That you get more and more granular about how subtle these differences can be. And, you're talking about this, at least the way you describe it, you still see room for people tweaking things, right? Tweaking, intent, tweaking meaning. You're talking about also this embodiment challenge, and how do you add all this visual context and experiential context to things. But I guess my question is, how do you foresee this happening? Because just as an example, when I interact with a model, and through like a chat-based model, depending on what I'm trying to do, I may have to iterate a bunch of times. And maybe it's going to be, depending on what I'm trying to do, it's actually going to be impossible to arrive at the results through prompting alone. Maybe I'm going to have to just get the text and start tweaking it and feed it back. It's like there's a limit to what you can do in this architecture of like prompt response. Maybe you say, make my text extra spicy, and now it's too spicy. Now a little bit less spicy, and it's hard to play with these parameters when it comes to getting language to be exactly what you want it to be. And my question is, do you think we have current tools that allow us to reach this idea, or do you think we have yet to develop these tools that allow us to author text or think about text in this way?
Yeah, so I think that would be a dream of AI tools, but it's not yet there. Like what I'm hearing from you is extremely good instruction following capabilities, also with limited information. So you should be able to just give it a tiny bit of instruction, or Rodrigo gives it a tiny bit of instruction and it gets what you want. You don't have to like fine tune and change the weight. So my goal for multilingual AI would be like, yes, single model, but that is so good at following instructions that I can do what you want and what Rodrigo wants without me shipping two different models. Now, I also think it's important to do, like, for instance, you might be able to connect like your computer environment, like your Slack, your email, and whatever, so it can get context in that way. Maybe it would also provide very limited instructions. But yeah, again, that's a dream. Everybody is building towards that, but it is certainly not there yet.
Yeah, I find that fascinating because it's like, for me, there's still room for a need for someone to look at text.
Yeah.
And the question that I have every day is how and in what capacity. And you're talking about, again, we're approaching the same problem from different angles. You're looking at it from a large language model capacity. It's the way I understood it, becomes a matter of basically context and instructions, and being able to have just the right level of context that with a very little instruction, it gets it, it's like you just say more formal or more whatever, and it understands you and understands exactly that your more formal is different from Rodrigo's more formal or mine more formal. So it gets that nuance. And then from my perspective, or our perspective, we're trying to create an environment where humans can actually touch the text without necessarily thinking about a model, but having that tool infer from their behavior what's going on, and then being able to regurgitate something that goes along that line as well. My question is, in your opinion, will language ever be something, or multilinguality ever be something that simply doesn't require humans to verify or author or change in any way? Or do you think you need fundamentally people in the loop for some reason?
Yeah, well, I think if we think about like, so if there's a really high stakes task, chances are you're not going to just trust a single human without any oversight to do this task. Like maybe you'd have another person look at it. So I think that's a fundamental limit on AI, in that you probably, especially in very high stakes scenarios, want not just one human to check it, but multiple humans to check it. Yeah, given the context, I would not feel comfortable just letting the AI go. And
but you're framing it as a matter of stakes, and like in low stakes, you think it's okay.
I think it's like efficiency trade-off. Like if again, like if I'm going to text someone that I really trust and I know they're going to give me the benefit of doubt on anything, am I going to pay like somebody to check it? It's going to take so much time, or am I just going to send it off? But if it's things I care about more, then yeah, the higher the stakes go, I think the more and more important it is for people to be involved.
Yeah. I just think it's interesting because, again, the thing of stakes, right? Sometimes the people that are going to give me the most slack and where I'm going to have the most wiggle room are also the people that I really want to take care and think
Yeah.
about, make sure that the message is just right. The
Yeah.
tone is just exactly what I mean it to be.
Yeah.
But at least I mean, I tend to be pretty picky about language. And I guess that's I don't know. I see a world where like people are like, okay, everything that's low stakes, like let's say it's a YouTube video, and it's nothing serious, and you just want to be able to watch that YouTube video in another language, and you wouldn't have access to it otherwise. Sure, and you take it with a grain of sand. At least you can understand it. I see that like there's a very democratizing aspect to multilinguality, right? You
Mhm.
can give access to so much more people, and I see immense value in that. But then when it comes to interpersonal communication, whatever it can be, when it comes to things that move people, whether it's an ad or whether it's, a description on a website, and even if a human doesn't change anything at all, I still feel like we need an author behind
Mhm.
something. I
Yeah.
still feel like I'm not going to pay as much attention to something that I think was machine translated, even if it's unaltered by you. Let's say, I have a machine generated text. I have another one that's identical. The difference is that you signed the second one. You said this is, verified and authored by Kelly. I'll
Yeah.
I'm going to value that way more than the first. And maybe that's just a bias. And maybe my kids and their kids won't have any more like a anti-machine bias. But what are your thoughts on that?
Yeah, I'll give you another example that happened literally today. So somebody sent me a research proposal and they said, "Hey, I wrote this research proposal. By the way, I used help from Gen AI, like just to let you know." And I was like, "Okay." So I read this and there's like a little bit of inconsistency. And then I'm thinking, wait a minute, did this inconsistency come from the Gen AI system, which I'm fine with them using it in this circumstance to save some time, whatever, did some summarization. So I was like, is this error because of them, in which case I need to address it because we've had a misunderstanding? Or is it just that the model popped out this thing, they didn't really mean that, I'll just ignore it? Yeah, and I did have direct questions about that today. So I decided, because I was unsure who authored that, him or the AI, I did put a question and it'll need to be resolved before we continue. But that is just one instance of, yeah, not being sure whether it was AI or human generated. So then not knowing how to act as a result and not trusting it as much because it could have been AI generated.
Yeah, that's super interesting because then you on one hand you add so much more accessibility to content, you create so much more content,
Mhm.
and on the other hand the content becomes so much less trustworthy. There's always
Mhm.
a sprinkle of doubt, who wrote this.
Yeah.
And if anything, models can be incredibly convincing and persuasive. I mean, I can ask any model right now that's good, prove to me that the earth is flat, and I'm going to get a really good answer, really good
Yeah.
one, really good one. Like all the arguments are going to be there.
Mhm.
And in general, I would just say, it's really interesting what you're saying because we're talking about truth, we're talking about agency, we're talking about authorship, and I just feel like more than ever these things are very much up for grabs. I don't know how you feel about that.
Yeah. I mean, mixed feelings in all directions. We have a safety group at Cohere who deals with questions like you said. Yeah, mixed feelings about all of this. But in general, I do believe that if we have a technology, then people should be able to equally access it. And that usually means accessing it in the language that they are comfortable in. So that's what I think about every day.
No, I agree, and that makes a lot of sense to me. And I really appreciated everything that I learned from you, Kelly, today. It's very um, eye opening for me. And again, I love the idea that there are different people from completely different perspectives working on similar natured problems, if not the same. And I'm really grateful for your time because if anything, I think that our space is very closed onto itself and doesn't
Mhm.
really consider the fact that maybe there are better and simpler ways already available to solve the same problems. So yeah, I'm super grateful. And I don't know, Rodrigo, anything that you'd like to add?
No, I think we are closer to our time. Then I I'm also grateful. Of course, I still have a lot of questions, and even after all this conversation, and mostly about how to bridge, these two worlds between this automated version, because basically our industry with the human in the loop, we are collecting and editing all these outputs and editing and giving and reasoning why we are changing, and but the LLMs, they are not getting all this output, this reasoning back. You know what I mean? In this process of learning, of course, they have tons of data, but not exactly, I would say, in this kind of correction or editing, phase that could improve. Yeah, but a lot of other questions. But I think maybe that it's a matter for next conversations.
Yeah, thank you so much.
Yeah, that's my only my only issue is that now I'm ready for 10 more conversations.
Yeah, okay, let's do it.
But thank you so much, Kelly. Really appreciate it. And if people want to follow your work, where should they go?
Yeah, sure. So I have a research website. Just look me up, Kelly Marchisio, online. You'll find some stuff. I have my Google Scholar page, various videos. So I think I'm one of 2 Kelly Marchisios that I know of in the world.
Oh,
I met one virtually when I was a teenager. She was in France. So I should be the only one that you find a lot of hits for online. If it's a very good horseback rider, it's not me, it's the other one.
Good to know. Good to know. I won't get that mixed up.
Yeah. All right.
All right.
Well, thanks so much.
Thank you, Kelly.
Thank you.
Bye bye.
Bye bye.